I personally think the hardest part about learning synthetic division, everyone paying attention, is not panicking when I start teaching it that you don't understand it when I haven't even taught it. So I'll be in like the middle of the synthetic division and everyone's like, huh? Like, I don't know how this works. Like, I haven't even finished the example. And then by the time the example's done, you're like, oh, that was easy. Every single time I'm just like, so you could not panic halfway through when I'm teaching it and expect that you understand how to learn something when you haven't been taught it. That would be fantastic. Every year it drives me crazy. People are like, have their panic-stricken faces because they don't understand how to do an example I haven't finished teaching. It makes sense that you wouldn't understand how to do something I haven't finished teaching. Huh? Okay. So in order for something to be a factor, the remainder has to be 0. So you'd use your remainder theorem, and you'd look for a remainder of 0 in order for something to be a factor, because that means it goes in evenly. So we want to verify that x plus 2 is a factor of this. So remember, we could just use remainder theorem. So we have x plus 2. What would x equal? Negative 2. So we're going to plug that in, f of negative 2, and we're going to see if we get 0 for our remainder, or our y value, so that it would be an x-intercept. So I'm going to get negative 2 cubed plus 5 times negative 2 squared plus 2 times negative 2 minus 8, which gets me f of negative 2 equals negative 8 plus 20 minus 4 minus 8, which is 0. And this is my remainder. So if we use remainder theorem and we plug in the x value and we get a remainder of 0, we then know that the factor x plus 2 is a factor because it went in evenly. If we did this and we got like a number like 5, then we'd have negative 2, 5. That's just a coordinate. That's not an actual factor. Okay? It has to go in evenly. It has to have a remainder of 0. So, we're actually going to flip to the next page. We're going to factor cubic functions today. Okay, so this is not a hard lesson if you trust me and just do as I say for the whole first example and second example, and then you will think it's the easiest thing ever, okay? Unless you don't know how to factor quadratics, then that's on you, and you need to. Okay, so we need to figure out what we can divide into this that will get us a remainder of 0, because we need to get one factor first. So these are the possible x-intercepts come from 6. Possible zeros or x-intercepts are the factors of your constant, so the number without a variable. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So when we plug in an x, we need to get out a y of 0, correct? Is what we're going to need to do. We're going to need to input in an x and output out a y of 0. Input in an x and output a y of 0. Because remember, when we put it in, we're going to put in an x and we need to get out a y of 0 in order for it to be a factor. We agree? That's an x-intercept. If you input in some sort of x and you get out a y of 0, that's an x-intercept, yes? So could I do remainder theorem with 1, 2, 3, and 6, any of those, and then until I get a 0 in my y? Yeah. Would that take long? Possibly. So could you go and maybe cheat a little and type this into your y equals, and then go to the table of values and look for an x-intercept? Go. So type in the x cubed plus 2x squared minus 5x minus 6 into your y equals. Put it into your y equals. I got quizzes. Last call for quizzes.
Minus 5. Minus 6.
skilled person. We know this.
Okay, so you type it into your y equals, and you go second graph to get the table. Second graph. And what is an x-intercept? What's your lowest x-intercept? Pardon?
It's -1.
Has to be x, then what? -1 is the lowest? -3 is lowest. So we could use any of those that are x-intercepts, correct? Not y-intercepts. We could use any. You can arrow up and it goes, you get more. All right. You could use any of those points to draw the graph as well. But we are going, I'm just going to use the smallest one just for now. So everyone's paying attention? So I'm going to go x equals -3. Then I'm going to make an L. This is my synthetic division symbol. The L has to be large enough that I can put one row of numbers at the top and one row of numbers at the bottom before I hit the line. So there has to be numbers here and be able to put numbers here. Now we know that we actually have an x-intercept if we get a remainder of 0 in the end. Because then our input was -3, our output is 0. But instead of just knowing what the remainder is, this is actually going to factor it down. We're going to be able to get the factors out of it. What we have to do first is see if we can rocket count our exponents. So this is 3, 2, 1, and then when it doesn't have an exponent, it's x to the 0 actually. So 3, 2, 1, 0. So can I rocket count? Can I 3, 2, 1, 0 blast off? Kindergarten, come on. Didn't your kindergarten teacher teach you how to count backwards from 10 using rocket counting? 10, 9, 8. Well, you missed out. It would have been way more fun if you were rocket counting. Sad. Okay, so we found out you missed out on something in your childhood. That's fine. Okay. All right. So if I can count down my exponents, 3, 2, 1, 0, blast off. I don't need a placeholder for any of them. I'm going to use the coefficients. Coefficients are the numbers in front of the variables only. And I'm going to put them in the first row of my synthetic division. So I'm going to put a 1, because there's a 1 in front of the x cubed. Then a 2, because there's a 2 in front of the x squared. Then a -5, because that's in front of the x. And a -6. I love how the little blue boxes keep that. So I'm just taking the coefficients of the x cubed. Yes? Nothing crazy. Okay. Now bear with me. I am going to multiply, add, multiply, add, multiply, add until I'm done. This is not hard, but if you panic and freak out halfway through, you will make it hard. Okay? All right. So, we're going to drop the 1 below. Now I'm going to show arrows as to what we're doing, but later on when I use synthetic division, I'm not going to do these arrows, but they're just to show you what we're doing. Okay? So I drop the 1, then I'm going to multiply. -3 times 1. What is -3 times 1? So it comes up here. So I finished multiplying. So now I'm going to add. 2 plus -3. -1. I finished adding, so now I'm going to multiply. -3 times -1. I need to reset. Start my computer. 3 comes up here. I finished multiplying, so now I'm going to add. -5 plus 3 is -2. And I finished adding, so now I'm going to multiply. Oh my gosh. -3 and -2 is 6. Then I'm going to add, and I get 0, which is my remainder. If I do not get a 0 as a remainder, I probably pick the y-intercept instead of the x-intercept off my calculator. That happens a lot. All right. Okay. So this is called synthetic division. So I divided, correct? I took an x out. You see that? This was an x cubed. Do you see that? This answer, I wrote these all down without variables, right? Just the coefficients.
Yeah.
So these are the coefficients that are left when I divide. So if I took an x out, this coefficient, this number 1, is actually going to be x squared. Not x cubed, because it was x cubed. Then this one's going to be minus 1x, and then this one's just going to be minus 2. Now, if I type that into my calculator, I don't get that graph back. What the heck? Because I'm missing this factor. What's the factor of x equals negative 3? X plus 3. Has to go in front. Ooh. X plus 3. So guys, go to your Y2 and type that in. It's the same graph. Weird, because it's the same graph. This is just a factored form of the original, correct? Now, listen to this. This is a linear factor because it would make a line. And this is a quadratic factor. And I would stop here if I couldn't factor the quadratic factor. Can I factor x squared minus x minus 2? I can. So the x plus 3 comes down because I don't do anything with it. This is what times what gets me negative 2, and what plus what gets me negative 1. Negative 2, peanut gallery, negative 2 and 1. So that's going to stay in. Then this, because it has a 1 in front of it, I can go right to product sum, x minus 2, x plus 1. Now type that into your calculator. What do you suppose is going to happen? So when you're done factoring, you should know if you're right, because this is just the factored form of the original. Which every time you factored last year and in grade 10, you should have known if you were right or not. Because you could put your original x squared into y1 and your factored form into y2, and you should have got the same graph. They are the same. Okay, hands to yourselves. Kindergarten. Okay? So these are the factors. And now we just factored something that is larger than x squared. Okay, we're going to flip over. I only moved it because I knew some people would panic. It would be kind of funny. Now you keep. And by people, I mean Hannah. She threw out a wait before I even moved the page, so I had to move it then. Because I felt like, you know, when someone tells me not to do something, I feel like I should. It's a bit of a thing. It'd be really hard for me. I intrusive thoughts when I hit the red button. All right. So we're flipping over. And we have another x cubed. Okay? We're just going to factor these right now. We're not going to solve them. So my possible zeros or x-intercepts come from the factors of the constant, which is 15. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So I could try all of these out until I get an x-intercept, being the remainder of 0. Or how could I save some time? Type that into your y equals your calculator and look for an x-intercept. Go. Close. Okay. X equals negative 1. Sure. We know we're right if we get a 0 in our remainder. Before we write down anything, though, what should we check if we can do? Rocket count, now that you know what it is. I can't believe you missed that in kindergarten. 3, 2, 1, and then this would be x equals 0. Blast off. So if we can rocket count, we put our coefficients down. 1, 9, 23, 15. if we couldn't rocket count, we would put in a placeholder of like 0x squared or 0x. Okay? So, let's go. Drop the 1. Negative 1 times 1, negative 1. Add it. 9 plus negative 1 is 8. Multiply. Negative 1 and 8 is negative 8. Add it. 23 minus 8, 15. Negative 1 and 15 is negative 15. You should be happy because
Equals 0. Your remainder is 0.
your remainder is 0, which it needs to be in order for this to be a factor. So our factor is x plus 1. That's our first linear factor. What is our quadratic factor?
Oh, no, it would be x squared.
1x squared, yep.
Actually. Wait,
Yeah.
no, let me keep going. Plus 8x
Yep,
plus 15.
yep. Can I factor that?
Oh, maybe, yes.
I can. I can't always. This one I can, though. I'm going to get x plus 1, which is my factor from the very get-go. And then what multiplies give me 15, that's give me 8, x plus 3, and x plus 5. So on your table, on your calculator, you would have had x-intercepts at negative 1, negative 3, negative 5. So these are the factors. Okay, you guys are trying B. There's a hint. You can't rocket count. So what is the one that you found? X equals what? X equals 5? So then you drop the 1. 1 times 5 is 5. Add it. 5. 5 times 5 is 25. Add it. Negative 2. 5 times negative 2 is negative 10. Add it. 0. And so I get 1x squared plus 5x minus 2. And it's being multiplied by what factor? Because if I put that in my calculator and this in my calculator, they don't match. X minus 5. Is there anything that multiplies to me negative 2 and adds to me 5?
No.
No, you're done.
That's the question we need to quadratic.
Quadratic formulas for solving.
Yeah.
Yeah. So if we just want the factors and you can't factor the quadratic, you're done. You have a linear factor and a quadratic factor, you're done. When we go to solving right away here this week, where we wouldn't be done, x equals 5 would be one of them, and then the other one would have to go to the quadratic formula. But for now, that's it. So I'm going to let you guys study tonight. Tomorrow we're finishing up cubic and quartic, the 3's and the 4's.